Avdi, Grimm, and I want to talk to you a little bit about confident code. I've given this talk a few times, and I used to introduce it as being about code construction. But I realized something recently. This talk is fundamentally about joy. It's also fundamentally about actually advancing slides. There we go. So, when I first got into Ruby, I got into it because Ruby is designed to make programmers happy, right? And you get into it, and you write something like this, and it's just the This is the simplest, this is the most expressive way I think I've ever seen in any programming language to say, do something 3 times. And, with the possible exception of small talk. So we start out, we start out programming with these bold expressive statements. And then, then our code meets the real world. And it starts looking more like this. And it starts getting cluttered up with conditionals and exception handling and special cases. And it turns into something that I think of as timid code. Timid code is code that lives in fear of its environment. It's uncertain, it's constantly second-guessing itself. It's filled with digressions and provisos. As a result of this, it's constantly mixing together input handling and business logic and error handling. And the net result of this is that there's this extra cognitive burden placed upon the reader of the code. I realize that timid code is kind of like a poorly told story. I mean, code always tells a story, or it tries to, but timid code is like when somebody tells you a story and they constantly pause and say and I apologize, I know I'll do that in this talk. I'm still working on it. But one of these stories that's filled with digressions and they're constantly going back and saying, no, wait, I forgot to tell you part of the story. And code can read like this. By contrast, confident code is code that is sure of itself. It's a style of method construction that tells a story well. It says exactly what it wants to do. And most importantly, it has a consistent narrative structure. So before we go any further, here's the code that I'm going to be using for this talk. You can check it out if you want to. It is a sort of a trivial wrapper for the very important Unix utility Cowsay, which if you're not familiar with it, you can give it some text and it'll produce an ASCII art animal for you, which has a little speech bubble, and you can give it various options, so you can make the eyes bigger and stuff like that. And you can play with this while I'm talking if you want. So here's a very simple example of using cowsay.rb. So you instantiate a cow object, and then you can call .say on it with whatever you want the cow to say. And by default, it produces the ASCII art animal as the return value. So this is the primary method in Cowsay. It's the same method. You can all read this, right? What I actually want you to look at here is not the code specifically, but the layout, the flow of it, and the shape of it. And in order to help you do that, I've annotated it in terms of 4 parts of a method. So you've got the parts that are dealing with gathering input, parts that are dealing with the work of the method, You've got the parts that are dealing with returning results, and then stuff that's dealing with handling errors. I think you can break most methods down into these 4 parts. And what I want to propose to you is a style of method construction that takes these 4 parts and goes through them in this order: gathering input, doing the work, the business logic of the method, delivering results, and then, if necessary, handling any failures that cropped up along the way. So let's start with input gathering. To make confident code, we need to be sure of our inputs. When you're talking about gathering input in Ruby, you have to talk about duck typing. True duck typing is a very confident style, although sometimes I see code that masquerades as duck type, but really it's doing these not really duck type things. Like if you're saying, if you're checking, is this object a string? That's not duck typing. If you're asking the duck, can you quack before you tell it to say something, that's not duck typing. Duck typing treats the object like a duck and assumes that if it is not, it will complain. The opposite of duck typing is typecasing. It's switching on the type of an object. And there's actually a name for this as a code smell. It's the switch smell. And you see this in Ruby code in the form of case statements on the type of an object. You see it in terms of checking for method existence. That's checking the type of an object. And you see it in the form, most often, of nil checks. Nil class is a type too. If you're checking if an object is nil, you are doing a type check. So I want to go through 3 strategies for dealing with uncertainty in input to make your code a little bit more confident. First of all, if you look in the Ruby standard library, you will see that it uses the Ruby's standard coercions liberally. You see 2s, 2i, 2a, 2sim. You see these all over the place, and this works out really, really virtuously because you have things like the open method. I can create a path name object, which is not a string. It's a special object for holding path names, but I can pass it to open, and it opens the file. It just works because open calls 2s on its argument before trying to open it as a file. So I recommend using these liberally in your code. If you know you need a string, ask for a string. If you know you need an array, ask for an array. And a great way to ask for an array is to use Ruby's built-in array method. I think of this as kind of the arrayification operator. And it's not really an operator, but I think of it that way because you can put anything into it and it will give you a sensible array in return. So if you put an array in, it'll give you the same array back. If you put a singular object in, it'll give you that same object back wrapped in an array. If you give it nil, it'll give you an empty array. So you'll always get an array out. And you can be very confident of that. So here's an example of using array. We're passing a message into our Cowsay method. And that message might be a number of things. It might be a single string. It might be an array of strings. In pathological cases, it might even be nil. So if we have this case statement to deal with that uncertainty, if we replace that case statement with the arrayification operator, it just goes away. It just works. It's a one-liner. And it's a much more confident line of code. Sometimes we can't rely on, sometimes we can't rely on there being a coercion method which suits our purpose. We need to turn an object into something that it is not. There's no consistent 2i or 2s that gives us the coercion we want. And this is a case where the decorator pattern can really come in handy, where you should just sort of glue a few extra features to an object, basically. So here's a candidate for some decorator code. We have this option to the say method, the out option, which is where we want to put the ASCII art. So it could be the return value if it's not specified. It could be a file we want to write it to. It could be anything that responds to the insertion operator. And And so we have this case statement, and this case statement here, all it's there for is, for debugging purposes, we want to be able to report where we wrote the output. But in order to do that one line of logging, we have to do this big case statement because there's no consistent way of describing the output type. So let's encapsulate that. Let's pull that into a method called Cowsay. And what this will do is that it'll pull out that type case. Sometimes you can't get rid of typecasing completely, but you can at least sort of isolate it out. And this is going to pull it out, and it's going to say if the out option is a file, then just pass it through. That's exactly what we expect to deal with. If it's nil, then we'll instantiate something called a null sync, and we'll look at that in a second. If it's anything else, we'll instantiate a decorator called the generic sync. And how are those implemented? Well, here's the implementation of both of those. Null sync is just a really basic object which supports a path method, and it supports the insertion operator, which does nothing. Generic sync uses Ruby's symbol delegator class to create a really simple decorator which will pass every method on to its underlying object, except it defines a custom path method so that we can always depend on that path method being there. Now we replace that line of code with this call to cowsync, and what we have now is we can confidently say .path on whatever comes out of that. Whatever comes out of that, whatever it is, we know that it'll have a .path method. And now we have this much more expressive and confident line of code where we can easily log where we put the output. Sometimes you have values coming in that you just can't do anything with. They're not a duck. They're not even a bird. Eventually, they will probably cause an error. They'll probably cause some no method error to be propagated out somewhere down the line, but possibly not without doing some damage first. And they might be, it might not be clear where that error originated. So to avoid this case, your code needs to be assertive, and it needs to be assertive about what inputs it will accept at the edges of your interface. What we're talking about here is preconditions. Preconditions are part of the design by contract methodology of software development, but you don't need a big design by contract framework to do this. You don't even need an assert method. A simple precondition might look like this. And I apologize for the people that are looking at this screen. It seems to be stretching things out, but this precondition here, what it says is we have an option called cow file. A cow file is basically a template for the ASCII art that's produced, and we're going to verify that if it's specified, it is not just white space. We can't deal with a file name that's just pure white space. Kind of a contrived example, but we raise an exception right at the top of the method before letting that go any further into the method. Now we don't have to deal with that possibility any further into the method. And it's self-documenting, because if you're reading through the code, you see, this is the first thing you see. You see this method will not accept a blank cow file. If we want, we can clean that up a little bit. We can write an assert method which makes that statement a little bit more concise. Another way of dealing with values we don't know how to work with is to simply ignore them. And a way to do this is to use a guard clause. Guard clause is kind of like a precondition, except it doesn't raise an exception. So it's just a clause that goes at the very beginning of your method, and it short circuits the method if it sees that it's got an input that it can't deal with. So that message might come in as nil, and there's nothing we can reasonably do with a nil message. We're not going to create any ASCII art for that. So we just have this return empty string at the very top of the method, if that happens. And the nice thing about this is that now we don't have to deal with that special case anywhere further down in the method. We don't have to think about the possibility that message might be nil. So we're trying to avoid these special cases, but sometimes you can't avoid having special cases in your code. Sometimes you need those special cases. And there's a pattern in object-oriented programming for this case, and it's called, not surprisingly, the special case pattern. And the idea is, if you have a special case that you have to handle, represent that case as an object itself. So here's some candidate code for applying a special case. After we call the Cowsay subprocess, we have to check the exit status of the process to make sure that it didn't fail. And so we've got this code that checks for that. But there's a kind of a complication. In certain cases, the exit status might be nil. There might not be an exit status object. We're expecting to find a process status object there, which responds to .exit status, but it might be nil. And so in this code, you can see two different ways of dealing with that lack of confidence. The first way is and. So we say status and exit status.exit status to check that status is not nil first. The second way we do it is we use try, which is in active support, and it's basically just syntax sugar for that and. But it doesn't really resolve the fundamental issue, which is that we're not confident about what that status variable contains. What if instead, before we use that status variable, we checked to see if it was nil, and if so, we replaced it with a quick little special case object. And for this, I'm just using OpenStruct to create a little ad hoc object, and the only thing it responds to is exit status. And that's fine, because that's all we need. That's the only method we care about from this object. And so if it's not there, we replace it with this ad hoc special case object, and now the code just works. It doesn't have to check that status variable before it calls anything on it. Another way of dealing with this, these special cases, is something called the null object pattern. So this is based on the observation that the special case, more often than not, is nil. And more often than not, the way we want to handle the special case of nil is by doing nothing. So a null object is an object that basically exists to do nothing. Here's a very basic implementation of a null object. We implement method missing to do nothing. So it'll take any message, any method, and it'll do nothing and then return itself. And we're also implementing the nil predicate to say this object is kind of like nil. And we also make a little helper method called maybe, which just helps us construct these null objects, and it basically replaces nils with null objects. Passes other objects through, but if an object is a nil, it gives you a null object back. So we can use this to make our code a little bit more confident. By the way, this is something, this particular variety of null object is known as a black hole object because it returns self, you can nullify arbitrary chains of execution. Here's an if statement where we say if the user has specified, the client has specified that out option, then write the output to that variable, otherwise don't. We can replace that with our little maybe helper, which will construct a null object in the case that that's nil. And now we can confidently write output without any kind of conditional there, because we know that even if it's nil, it'll be replaced by a null object, and the null object will just take that input and do nothing with it. You might have noticed a trend at this point, going through a lot of strategies to get rid of nils. And I really think nil is kind of overused in Ruby code. It represents so many things. It can mean there was an error. It can mean that there's just missing data. It can be a flag for default behavior. It's the default value for uninitialized instance variables. It's even the default return value for things like ifs and unlesses if you hit the unhandled case. So, and as a result, I find that nil checks are the most common form of timid code. So I try to eliminate nils wherever I can find them. There's a few strategies you can use to do that. One of them is to use the fetch method. How many people are familiar with fetch? Few people. All right. So fetch is on pretty much all the standard enumerables, all the standards collections in Ruby. And what you do is you give it a key, and it acts like the square brackets, like the subscript, except you give it a key, and if that key is not there, it will execute whatever fallback action you specified in the block, which could return a default value, or it could raise an exception, or it could do something else. So you can use fetch as an assertion. You can say fetch instead of using square brackets, and by default, if you don't specify a block, it'll raise an exception. If you don't, if that key is not there. If the required key if you have a key where you want to be a little bit more explicit about what went wrong, you can pass you can raise an explicit exception in the block there. You can use it for defaulting. So instead of using the OR operator, you can specify a default value in the block to fetch. How many people deal with this kind of error on a daily basis? No method error on nil class. And how often do you find yourself thinking, where did that nil even come from? There are so many places that nil could have come from. Can anyone tell me what's different about this error message? So here we're replacing, we're replacing the nil case, the unspecified case, with an explicit symbol called no logger set. What's different? What's better about this error message?
You know exactly where it pinpoints.
It pinpoints where it came from, exactly. You see this you see that the no method error is now on the symbol no logger set, and you can grep for that. You can search the code base and you can figure out exactly where you failed to specify a value that the code was expecting. Another thing you can do is you can use a null object for defaults. This is great for loggers. If you have optional logging, you can just make a null object your default logger, and then you can just make your log statements all throughout the code, and they'll just do nothing if no logger is specified. You don't have to check for it. All right, so that was all the first step in our 4 steps of a narrative method. The second step is performing work. And there are a couple of styles of performing the business logic of a method that I find lend themselves to confident coding. So one of them is chaining. Chaining is a very Ruby-ish style. You chain a bunch of methods together to get a result. And chaining is great because if you're not sure if that initial object exists, if you're not sure if it might be a nil, you can just wrap that initial object and maybe get your null object in there. And if it's not there, then the whole rest of that method is just a no op. The whole rest of the method gets nilled out. So you don't have to do checks at every step along the line. Another confident style is the iterative style of getting work done. And if you've done any work with jQuery, you're probably familiar with this. In jQuery, you almost never work with singular objects. You always work with collections. Sometimes they're a collection of one object. Sometimes they're a collection of no objects. But you always work on collections. The thing about working with singular objects is that they're implicitly one or error. Either there's something there or there's a problem. The thing about working with collections is that they're implicitly 0 or more. There's no error case in there. It's just 0 or more. If there are 0 things in there, then nothing happens. Cowsay uses this style. So messages might be an array of messages. So it just converts. It just goes ahead and at the very start converts message to an array if it's not already. And then it iterates through that array. And if there is nothing in the array, if it's empty, then nothing happens. There's no exception for that case. All right, so step 3, that was gathering input, performing work. Now we're on delivering results. Don't have a lot to say about this point, except be kind to your callers. Don't make them deal with nil if they were expecting some other kind of value to come out of your method. Consider returning. If you can't return the object they were expecting, consider returning some kind of special case object instead. Or if there's no special case object that makes sense, raise an exception, but don't make them have to check for the nil case. All right, so that's our first 3 steps. Our final step is handling failures. And the first thing I'll tell you about this is try to put the happy path first. If you're reading through the code, you want to see what the code is supposed to do. You don't want to get distracted by all kinds of tangents about, oh, and this might happen here, oh, and this might happen here. What we want to do is we want to try to put that failure handling at the end, or isolate it out to separate methods. So here's the digression in the code. We looked at this code a little bit before. We're checking in the middle, right after we do that popen call to actually run the Cowsay process, we're checking the exit status. And And this is an interruption in the middle of understanding, if you're reading through the code, this is an interruption in the process. Now I've got to think about, oh, sometimes the exit status might be bad. And what we can do with code like this is we can extract it out to something called a bouncer method. And a bouncer method's job is to either raise an exception or do nothing. That's its whole job. And here's a bouncer method that yields to its block, and then it checks that one condition, that exit status condition, and either raises an exception or it doesn't. And that's its only job. And then we can wrap that around our call to popen, and it becomes much more expressive because now we're not interrupted by that glaring raise right in the middle of the narrative of the code. Here's another interruption. A begin, rescue, end wrapped around the reading of the results back from the process. And it turns out in certain cases we might get an epipe error. And so we have to handle that. And you're reading through the code and you get to a block like this and it completely throws you off. I mean, you were thinking about making ASCII art animals, now you're thinking about epipe errors. And by the time you get to the end of a digression like this, you might not even remember what you were reading about in the first place. Let's extract that out again. This time we'll use something called a checked method. And a checked method is just a version of a method that you're already calling, except it encapsulates failure handling for that method. So we're going to make a checked popen, and this one is going to always check for epipe errors. Apply that to the code. Now we're not interrupting the narrative of the method to talk about epipe errors. So when we apply all of these refactorings, we come up with something that looks like this. We've got those parts of the method. First we're gathering input, we've got doing the work, and then we've got returning results, and they're in that order. And all of the error handling has been factored out to other methods. So what can we say about this final product? Well, it does have that coherent narrative structure that I'm talking about. It has lower complexity, and I'm using this in the specific computer science meaning of it has fewer paths. It is not necessarily shorter. The code that I just showed you was a little shorter, but that's because we pulled all this code out into separate methods and helpers and null objects and stuff like that. And in fact, the final result is a little bit longer. And this style of coding is not about reaching the most concise possible statement of what you're doing. It's about being expressive. It's about telling the story well. And that might mean that it actually comes out a little bit longer. Why do we care? What is the point of trying to write code in this style? Well, for one thing, we said it has fewer paths, and we know from research that fewer paths in a program are associated with fewer bugs, so there's that. It is typically easier to debug. Usually methods fail more quickly rather than letting bad values get deep down inside and then spring a bizarre and inscrutable exception on you. It's more self-documenting. There's this old saying, write your programs for humans first and then for the computer. And it results in methods that express themselves better to the reader, and that might be you in 6 months. But I think most importantly of all, the reason is joy. It's getting back to that beautiful expressiveness and that feeling that we get when we say 3 times do put S hello world. That feeling of just writing out exactly what we mean and nothing more. So that's all I've got. Thank you very much for listening, and I think I have 30 seconds for a question. Keith.
I think most of what you said was not confident code, it was beautiful code.
Thank you.
So how do you feel? You showed the chaining, and chaining, of course, in Ruby is very common with enumerable objects. And I thought that fit well. But of course, when you chain on enumerables, you create copies of them. And if you use the baying methods will return nils. Do you feel that that's incorrect behavior because it then introduces a nil into the middle of the chain?
Do I feel that using bang methods is incorrect, or the fact that bang methods return nils into the chain, that's incorrect behavior? Generally, unless I have a very specific reason, I'm not using the bang methods. So I'm usually using the non-destructive versions because I'm not gonna optimize until I have a profile or a result that says I have to optimize. That answers your question. I think I'm out of time, but please feel free to catch me in the hallway or at lunch if you have any other questions. Thank you so much.